Hello.
Hello.
Alrighty, you guys are right on time and ready to go. We have to check your homework from last night. So we need to be on page 523. Okay. You see, Lauren, how did you think the homework was? Was it okay?
It was not that bad. It probably took me like 15 minutes to do it all.
Okay, good.
There was only one that kind of confused me.
Okay, all right. Good. We'll go over those.
45.
Today.
Yeah.
Number 45 is confusing.
Same.
Okay. Oh, yeah, that one. When I did them, I was thinking that was the most confusing too.
Yeah.
Okay, we'll go over all of them.
Computer.
But we'll start at number
computer time because of it.
Number 13 on page 523. Okay. Jumping spiders can be found in homes and barns. That was a little disturbing when I read it. The height of a spider's jump in feet after T seconds can be modeled by a certain expression. First, they want you to factor that expression and find the spider's height after 0.1 second and after 0.5 second. Okay, so we're going to start off with part A. So let me just write the expression down, which is 12t minus 16t squared. Okay, and I'm going to make a list of my kiddos. You're all here. Okay, so Abby, you're at the top of the list. So what did you factor? How did you factor that, Abby?
I did 4t
Mm-hmm.
times the quantity of 3 minus 4t.
That's it. All right, I'm going to hold that up so everyone can see, right? 4t times the quantity 3 minus 4t. They want to know what is the height of the spider's, what is the spider's height after 0.1 second? Wherever you see a t, you're going to fill in 0.1. Okay, so you're going to do 4 times 0.1 and then 3 minus 4 times 0.1. And you're going to use a calculator. That'll give you 0.4 times 2.6. All right. Emma, what did you got for part B when you did that multiplication? Emma, you're mute. There you go.
Okay, yeah. I don't know if I got 0.104 or 1.04.
1.04 feet. Yeah. Okay. So put in 0.1. Right. You're going to use your calculator probably. Okay. And this one says after 0.5 seconds. You're doing the same thing. You're putting in 0.5. So this one's kind of easy. If I do 4 times 0.5, I get 2. 3 minus 4 times 0.5. So 3 minus 2 is 1. 2 times 1. I could kind of do that one without my calculator. But Emma, what did you get for part C?
The way I used my calculator was wrong, so can I just fix something real quick?
Oh, yeah. Let me just move on to Gavin to see what Gavin got for that one. All right, Gavin, you're doing part C. And you have to unmute, Gavin. Okay. Are you there, Gavin?
I am.
Great. Okay.
I don't know if I got this right.
Okay.
So, do you want me to? Oh, maybe that was out of nowhere. Sorry.
Okay. Wait, by wasting time, I just seen with Gavin.
Jane.
No, he's working.
Jane, I'm doing my
I was
homework.
just doing that because I didn't have a pencil.
All right, Gavin. We have to go on, Gavin. So either answer me or mute it, and I'll go to Karen.
I said 2 to times the parentheses 3 minus 2.
Good. And then keep going.
And I'd use the distributive to change it into 6 minus 4.
Okay. What'd you get?
2.
That's it. 2 feet. Good work. Okay. So the really disturbing part is after half a second, the spider jumped 2 feet. All right. We're going to go to the next one, number 14. There is a 4th of July celebration. A rocket is launched straight up with an initial velocity of 128 feet per second. They model this 128t minus 16t squared. We have to factor out the greatest common factor. So, Karen, what did you get for 14a when you did the factoring?
So at first I got 128t minus 16t squared. Then I said like 16t in parentheses 8 minus t.
Very good. 8 minus t. Perfect. 16t in parentheses 8 minus t. I guess that was kind of for part B. I jumped a little bit. Good work, Karen. Okay. Part A, they said, what is the greatest common factor of each term? And so for part A, the answer was 16. But Karen got that because that's what she used in part B. So good work, Karen. Okay. So part A is 16. Part B is that factored part that Karen said, 16t times the quantity 8 minus t. Okay. The next part says, will the height of the rocket be greater after 4 seconds or 6 seconds? Okay, so I'm going to go to Lauren. What did you say, Lauren?
I said after 4 seconds.
How high is it after 4 seconds, Lauren?
256.
Good. Wherever you see a T, you put in a 4, and you get 256 feet. Okay? What happened when you put in a 6?
I got 192 feet.
Yes, that's right. So the answer is after 4 seconds. Okay. All right, so you put in a 4, you get 256 feet. You put in a 6, you get 192 feet. So the answer is after 4 seconds. My question is why? So I'm going to go to Matthew for that one. Matthew, why is it higher at 4 seconds? If I'm shooting this rocket up into the air, shouldn't it be higher after 6 seconds?
Because it was falling back down.
Good, right. The rocket goes up. It comes down, right? It doesn't keep going up forever
What
and ever.
goes up must come down.
Right. Okay, so good. So that's why, at 4 seconds, it was higher. After 6 seconds, it had already started to fall. Okay, good job. All right, we're going to number 45. Maybe I should call this the dreaded number 45. This is the one you guys are telling me was the worst. I agree. When I did it, I thought so too. Okay. But you guys can do this. Use the drawing. Write an expression in factored form to represent the area of the blue section. I think the in factored form is kind of confusing for that one. If we wanted to find the area of the blue section, it's a rectangle, right? So we would do length times width. So the length is B, the width is A. All right, so for part A, our answer is just AB. Okay, we're just finding the area of the rectangle, length times width, which is B times A. I'm going to write it as A times B because I like to go alphabetically. Okay, the second part said, write an expression in factored form to represent the area formed by the outer edge. So they want the area of the whole big rectangle. Okay, so it has 3 on the top and 3 on the bottom. And then like the rest of that blue part from top to bottom is A. So the width of that is A plus 6. Okay, that's just the first part. I'm doing the width. So it's A, and then there's 3 on top and 3 on bottom. And then the length is B plus 6 because the length has 3, and then the blue part is 6, and then there's 3 on the other side. So this is part B. A plus 6 times B plus 6. Length times width. Part C said, write an expression in factored form to represent the yellow part. So if I wanted to do just the yellow part, I would take the whole big rectangle and subtract the blue one. Okay?
Can I see what I got?
Yeah, go ahead. Go ahead, Matthew. Was that you?
Yes, I said basically the answer for B, but then I subtracted AB.
Mm-hmm. Yeah, that's good. Then they want us to like factor it out. So for part C, Matthew's right. He said he did the answer for B, and then he subtracted AB. I'm going to FOIL B, okay? So we take the answer for B, we FOIL it. We get first terms AB, right? Outer terms 6A plus inner terms 6B plus last 36, and we subtract AB. I have an AB in the front, and I'm subtracting an AB, so those ones just cancel out, and I'm left with 6A plus 6B plus 36. And they want us to factor that. So I'm going to go to Nathan. Nathan, what can I factor out if I have 6A plus 6B plus 36? You'll have to unmute first, Nathan. Go ahead.
The 36.
Yep. So what can I factor out? 6A, 6B, and 36. What's the biggest thing I can divide all of those by?
6.
Good. So I factor out a 6, and I'm left with A plus B plus 6. That's our final answer for that part. Okay. I agree with you guys. That's the worst one. All right. We had more, though. We went on to number 46, and it was about fireworks. All right. Fireworks shells fired from the ground. The height can be modeled by, and they give us an expression. Write the expression that represents it in factored form. So we have to factor this. I'm going to go to Nicholas. Nicholas, we're on 46A.
The factored form I got was 8t times 30, and then times the quantity of 33 minus 2t.
Yes, good. Okay, so we have 264t minus 16t squared. Biggest number you can divide those numbers by is 8, and you can also factor out a t. All right, so we have 8t times 33 minus 2t. What is the height of the shell 0 seconds and 16.5 seconds after the launch? Okay, Nicholas, I'm going to have you do the second part too. You're going to do A and B. At 0 seconds, how high is the firework, Nicholas?
At 0 seconds, 10 inches, like off the ground, because it said it was fired. Like
All
the
right.
height of it was 10 inches.
Okay, so I'm going to put a 0 in for t. Okay, so 8 times 0 times 33 minus 2 times 0. Okay, all right, Nicholas, what is 8 times 0?
0. The answer.
And then in the parentheses, when I have 33 minus 2 times 0, that's just going to be 33, right?
Mm-hmm.
All right, what's 0 times 33?
0.
0, good. Okay, so, and you're saying 10 inches just because it is
10 inches, like it was fired. Like that's
okay. Yeah, I think they mean the height off the ground, though.
Oh, okay.
So yeah, I see what you're saying. All right, we're just going to say 0 for that. Yeah, the height of the shell is 10 inches, but I think they're talking about how high off the ground is it. Okay, so 0 feet. And then did you put in a 16.5 seconds?
Yeah.
And what did you get?
I also got 0.
Yeah, right. And that's going to be because of what Matthew had said before. it's going to go up and it's going to come back down. So that firework, before it goes up at all, it's 0 feet off the ground. And then after 16.5 seconds, it's at 0. Okay. So for part C, that means the shell was on the ground then. Okay. Based on your solution, where was it? It was on the ground. It says the shell will reach its maximum height in 8.25 seconds. What was the maximum height? I'm going to go back to Abby for that one. Abby, what did you get for 46D?
Don't think it. Wait, 46B?
D.
Oh, D? I don't have a D for some reason.
Okay. All right. That's all right. We'll go to Emma. All right. So you just had to put 8.25 in for T.
I got something really weird.
All right. What you get?
1,089.
That's it.
Wait, really?
Really? Mm-hmm.
I got 108.9.
All right. My book's giving me 1,089. Let's pull out our calculator, okay? And everybody, in case you didn't get 1,089, we're going to use our calculators. This is something we're definitely going to use a calculator for. We're not going to go ahead and do that on the side. So first, we're going to put 8.25 in for the first T. So we have 8 times 8.25. And that gives us a 66 on the outside. Right? On the inside, we have 2 times 8.25 is 16.5. 33 minus 16.5 is 16.5. Okay. So that gives us a 66 times 16.5. And that gives you 1,089. So yeah, Nicholas, I'm not sure where your decimal point came, but maybe you hit a decimal in there when you were typing it into the calculator. Okay, 47 is going to be similar. They give us expression and they want us to factor the expression. Gavin, what did you put for 47A?
Was 47A?
Uh-huh.
I put, I mean, I put, yeah. I was having some problems with this one. I thought it meant like kind of get down what the equation you start off, what you have to work with.
So we're taking that 440t minus 16t squared and factoring it. So we have to find the biggest number we could divide them both by.
8.
Yep. And we can factor out a t. All right. So 8 t's on the outside. Is that what you did?
Yeah.
All right. What did you get?
I
Go
8
ahead.
times in the parentheses 55 minus 2t.
That's it. You did it right. Okay. Part B says, what is the height of the rock 10 seconds after it's erupted and 20 seconds after? Let me go to Karen for part B. All right, there's 2 answers for that, Karen. How about after 10 seconds and then 20 seconds? Okay.
So what number are we on again? Sorry, I got lost.
That's okay, Karen. We're on 47B. So after 10 seconds, what is the height of the rock?
So I said 2,400 per second. That after 20 minutes or so.
Yep. Okay, 2,800 feet after 10 seconds.
Mm-hmm.
And how about after 20 seconds?
I said 2,400 per.
That's it. Feet. Mm-hmm.
Feet.
Perfect. That's it. All right. Good job, Karen. The rock reached its maximum height 13.75 seconds after it erupted. What was the maximum height? Hang on, my list went away. After Karen, I have Lauren. Lauren, what did you get for part C, the maximum height?
I got 3,025 feet.
That's it. 3,025 feet. Okay. So we're taking that formula that Gavin gave us. Karen put in a 10 and a 20 and got her 2 answers, and Lauren put in a 13.75, got her answer. All right, there was one more. At this point, you guys are probably getting really good at these word problems.
Palmer.
Yeah.
For my first C, I got 9,075.
All right, so we're going to use part A, right, that Gavin gave us, and we're going to put in 13.75. So we'll do 8 times 13.75. We get 110 on the outside. And then we have to do 55 minus 2 times 13.75. All right, 13.75 times 2 is 27.5. So 55 minus 27.5 is 27.5. All right, so that gives us 110 times 27.5, and we get...
Okay, I see my mistake.
Okay. You found out what you did? Okay.
Yep.
Awesome. All right. Remember, just as important as getting it right is going back and saying, oh, I figured out what I did wrong. And sometimes with these, it's just typing it into a calculator incorrectly. Okay. 48A. Again, we need to factor it. And Matthew, you're actually up next.
48.
48A.
I said negative 16 t to the second plus 6t minus 10.
Yes. Awesome. Negative 16, and then in parentheses, negative t squared minus 6t plus 10. Okay. Part B, from what height is the rider initially dropped? So this question's a little bit different. I'm going to go to Nathan. Nathan, what did you say? What was the height where the rider was dropped? This is like a ride, thinking of it like at Knoebels, right? It's a tower thrill ride. So you're starting up high. How high up were we starting, Nathan?
I didn't get these.
Okay. So when you're starting the ride, before you go on the ride, how many seconds have passed? What would we put in for T? This is before anything happens. We're going to use what for T?
T.
We have to put a number in.
Oh.
How many seconds have passed before anything has done? Right. So we're going to put in a 0. All right. So they're saying before the ride starts, how high are you? So you're going to put in a 0 for T. T's for time. So before the ride started, you're on this tower. How high would you be? So you fill in a 0 for T. All right. And that's going to mean you still have a negative 16 outside. And inside, you're going to have a negative 10. It's going to look like this. What's negative 16 times negative 10? Right? So what's 16 times 10, Nathan?
16 times 10 is like 100. Wait. 1600, like 1600.
It's just 160. You just add the 0. And a negative times a negative is a positive. So for part B, we'll have 160 feet. Okay. And then Nicholas, I'm going to go to you for the last one. At what height will the rider be after 3 seconds of falling? So you had to put a 3 in, Nicholas. And what did you get out?
I said 12 or 16 feet.
When you put in a 3?
Mm-hmm.
All right, let me try it. Negative 16 times 3 squared plus 6 times 3 minus 10. Okay. So let's do inside the parentheses first, okay? What's 3 squared, Nicholas?
9.
All right. 9 plus 18?
27.
Good. And 27 minus 10?
17.
Okay, good. So we have negative 16 times 17. All right, so I want you to multiply those together. All right, do you have a calculator handy, Nicholas?
No.
All right, I'll do it for you on my calculator. I'm going to do negative 16 times 17. I'm getting this, negative 272. Okay, so after 3 seconds of falling, the rider is negative 272 feet. And then they say, is this possible? So think about what the story is about, Nicholas. You're on this tower ride. It falls for 3 seconds. Can you be negative 272 feet?
No.
No.
Yes.
Okay, the rider can't be a negative number of feet in the air. I guess if they had like a hole dug in the ground or something and you went like below ground.
Yeah.
But,
Yeah. Why not?
But just saying there is no below ground, that just means this ride can't even last 3 seconds, right? Because if it lasted 3 seconds, you would have crashed into the concrete below, unless there was like this giant hole you could go into. So no, it's not possible because you can't be like a negative number of feet in the air. All right. I wanted you guys to go through those just to see, these are some ways that the algebraic expressions are used. You'll see these a lot when you go to Algebra 2 because these are all quadratic. So it's anytime something's in the shape of a parabola, when you're throwing a ball, when you're shooting fireworks or a rocket, things like that. So I'm going to have you do some review things for tonight. And then tomorrow we're going to start the section on factoring by grouping. It's still in this section, but it's the second part. It's like on page 521. But I'm going to have you guys do some review so you don't forget what we've been doing this whole chapter. So it's on page 547. Okay. So it won't be what we've just done now. It's going to be some review things. Page 547, numbers 14 to 25. All right. This is just to keep these polynomial skills sharp. And then tomorrow we're going to go back to factoring, and we'll be factoring by grouping. Sometimes we'll have to group when we're factoring when we have like 4 or more terms. Right? Here's your homework. Do you guys have any questions for me? All right. You guys can go to religion, but have a great day.
Bye.
Bye-bye. If you get stuck,
Okay,
come see me at
bye.
2 o'clock. Bye-bye.